Hey guys, one way to convert fractions to decimals is to use long division. So if I wanted or needed to convert 3/5 to a decimal, I know that this fraction sign really means division. So I can rewrite this as 3 divided by 5. So if you need a little refresher on long division, the first thing you would do is ask yourself, does 5 go into 3? And the answer is no, it doesn't. It's too big. So I would put a decimal after the 3 and add a 0. So does 5 go into 30? Yes, it does. 5 goes into 30 evenly 6 times. So I put my number 6 up top. I now take the number that I put up top and I multiply it with 5. So 6 times 5 is 30. I subtract that and my remainder is 0, which means I'm done with this problem. So 3/5 can be written as 0.6. This is what we call a terminating decimal because the decimal stopped. It ends. Let's do another example for perhaps a non-terminating decimal. So let's try converting 2/3 to a decimal using the same method. So again, I would rewrite this as 2 divided by 3 and ask myself, does 3 go into 2? No, it does not. So I add a decimal, add a 0. Does 3 go into 20? Yes, it does. 3 goes into 20 6 times. So again, I take my 6, multiply it by 3. 6 times 3 is 18. And I'm going to subtract 18 from 20. So 20 minus 18 is 2. I now bring another 0 down and ask myself, does 3 go into 20? Well, yes, it does. We just actually thought of that. It goes in 6 times. 6 times 3 is 18. I'm subtracting. You may see a little pattern here. So what would continue to happen is we would be repeating the same process. We would get 18, subtract, get 2. So this is what we call a repeating decimal. I would keep getting 6s here. Okay, so I can show that as 0.6, and I can put this line over the 6. So what that little symbol indicates is that that 6 is going to be repeating forever. So 2/3 as a fraction is 0.6 repeating. Now it's really important that you put that symbol there because 0.6 is not the same thing as 0.6 repeating. 0.6 repeating is a bigger number because we have numbers after here. This is really 0.60. Okay, let's do one more. So we covered a terminating decimal, a repeating decimal. Now, let's try converting 4/7 into a decimal. So again, I would rewrite this as 4 divided by 7. Ask myself, does 7 go into 4? No, it doesn't. So I'm going to put my decimal up top. Does 7 go into 40? Yes, it does. It goes in 5 times. 5 times 7 is 35. 40 minus 35 is 5. I bring down a 0. Does 7 go into 50? Yes, it does. 7 times. 7 times 7 is 49. Okay, remainder of 1. I bring down a 0. Does 7 go into 10? Yes, 1 time. 1 times 7 is 7. Bring down my 0. Does 7 go into 30? Yes, 4 times. I'm going to continue my work over here. 4 times 7 is 28. Bring down my 0. 7 goes into 20. Twice. 2 times 7 is 14. So as you can see with a problem like this, okay, my decimals they're going to keep going. So most teachers are going to give you a rule with which they want you to round to. Okay? Usually they'll tell you, or usually I will tell you, I like 2 places after the decimal. But in this case, we're going to keep 3. So I would say that 4/7, we can convert that to 0.571. Because if I look to the 4, if I remember my rounding rules, 4 is smaller than 5, so I would leave 1 the same. Okay? If I had a larger number here, I would round this up to 2. Okay? We could also use the symbol, and actually it's better, it's not really equal. Okay? We can say it is approximately. So approximately, we're going to use a little squiggle like that.